Hello students.
Hello, sir.
Welcome to the lecture. Today we are going to see a case study. So today for today's lecture I have taken a case study on isoparametric element. So this is the isoparametric element, right? So we know about the definition of isoparametric element, right? So in this isoparametric element you can see the given data, right? So what we have to find in this case is what is the coordinate of P. That is what you have to find. Right? Let us proceed to the case. So in this case, if you see this isoparametric element, the Cartesian coordinates are given, right? So you have to find the local coordinates. So let us proceed how to solve this problem, right? So in this case here, if you see the problem, here the x1 is 3. And here the x2 is 6. 8. 2. So this is what the x-axis at various nodal points, right? So similarly, if you take y, the first y coordinate is 1, 6, 5. Right? Next, the point P is located, right? The point P of x, y, that is the Cartesian coordinate that is given as 7, 4. So this is the given data for this case, and you are asked to find the local coordinate, right? So you have to find the local coordinate, that is epsilon and eta. This is what you have to find. So in order to find the values of epsilon and eta, there is a formula. What is the shape function?
So shape function determines the geometry of the element.
Yes, good. So here we can use the formula of the shape function. So in this case, if you see the element, the given is x and y axis. That is the Cartesian coordinates are given, right? You have to find the local coordinates at the particular point P, right? So in order to find this, you have to use the shape function formula. So a shape function is nothing but a shape function defines the geometry of the element. So in order to know the shape function, see how many elements are there in this, how many nodal points are there in this element? 4, right? So, there are 4 shape functions, n1, n2, n3 and n4. So in order to find the shape function for this case or any isoparametric element, there is a standard formula, derived formula, right? So n1, n2, n3, n4 are the shape functions, right? So in order to find n1, this is the formula, right? So n1 and n3, if you see n1 and n3, the epsilon and eta are entirely minus or entirely positive sign. And the next thing is n2 and n4. So here similarly n2 is 1 by 4 into 1 plus epsilon. Okay. 1 minus eta. Yes. So here it is plus 1 plus epsilon and 1 minus eta. Right? Similarly for n4 it is 1 by 4 1 minus epsilon. Very good. 1 minus epsilon and 1 plus eta. So this is how you have to remember this shape function formula. And there is one more rule that it states that the sum of the shape function should be equals to 1. So if you find the shape function at the different nodal points for this isoparametric element, so the shape function value, if you add all the 4 values, it should be equal to 1. It should not be greater than 1. So if you have the value greater than 1, which means that your calculation is wrong. So this is how you have to find the values. And if you see the Cartesian coordinates, right, the x and y, there is a standard formula. What is the standard formula? To find the Cartesian coordinate, x1 equal to n1 x1 plus n2 x2 plus n3 x3 plus n4 x4. Clear?
Yes.
right? For this case, that is y, right? To find y, it is n1 y1 plus n2 y2 plus n3 y3 plus n4 y4. So this is how you have to calculate the Cartesian coordinate. So if Cartesian coordinate is known, from this formula you can find the local coordinate. So this is how this problem to be solved.
Start.
So here the formula, if you substitute all the values of x1, x2, x3, x4, you will get an equation with respect to x. Similarly, if you substitute in the y equation also, you will get the equation. So these are the equations, right? So approximately these kind of equations you will get. Once these equations are solved, you will get the values of the local coordinates. Right? So once these values are found out, then you can substitute inside the epsilon eta of this shape function formula, and finally you can check whether your answer is right or not. So this is how you have to find the local coordinates for this case. So I hope this lecture given you a better insight to solve these kind of cases. That is, the local coordinates are to be found out, but the Cartesian coordinates are given. Right? So let us see. Let us meet in another class where the condition is vice versa. That is, the local coordinates are epsilon and eta are given, and the Cartesian coordinates are to be found. That we can solve it in the next class. I hope this case you have better idea. Am I right?
Yes, sir.
Yes. Thank you.